Alright, welcome back. We've got day 21A. And this is intro to solids, solid geometry. So there's the list. We're going to go through the list of solids. We're going to define each solid and do just some basic things about solids today. And then the next video we'll do a lot of the formulas that are related to the solids. So there's two types of solids. There is polyhedra and there is non-polyhedra. So what's the difference? Well, polyhedron, polyhedra is plural for polyhedron. One is polyhedron. So polyhedra have surfaces that are composed of polygons. Okay. Our non-polyhedra is basically when you're saying you have curved surfaces. Okay, at least one surface is curved. So for our list, I guess, of what we're going to discuss in this course, your polyhedra are your prisms, and your pyramids. Whereas your non-polyhedra, that's going to be your cylinders, cones, and spheres. Okay. And I'll put here underneath here hemispheres, which is half of a sphere. Okay, so these are the six solids that we're going to be studying in this unit. So we're going to go through each one here. So first thing we'll do is a prism. Okay. Now a prism is defined or is classified by the shape of its bases. Okay. And the key with this is the bases are always parallel and congruent. Okay, always parallel and congruent, the bases. So let's draw an example of a prism. Let's do a hexagonal prism. Hexagonal. So the bases here are hexagons. Now I'm going to draw a hexagon here. And you should, if you're trying to draw these, you should definitely be working in pencil because there's a lot of kind of areas where you have to go back and make things dashed. So then I'm going to draw another hexagon, the same size, but I'm going to draw a little higher up and to the right, and try to make it the same size. Okay. And now I'm going to try and connect corresponding vertices on the hexagons. So the top left to the top left, the top right to the top right, the middle of the right side to the middle of the right side, and so on. Now what's happening here is some of these I'm going to start making them dashed here. You can't see because they're kind of behind the solid. In fact, this in here should really be dashed. You can't really see these on this hexagon. Okay, so this is kind of a, you're looking at it kind of from above. All right. And again, I'm going to remind you, it's this. When I say to somebody, if I give somebody this picture on the street and I said, take this picture and shade in the base for me. They shade in the base. And they shade this in. This part that's sitting on the ground. Not the base. The bases are parallel and congruent. The bases are these things. This is a base here, and this is a base back here. Right? That's it. So don't, it's a trap. They say it's a trap. Now the dimensions, okay? We'll do different things depending upon what the base is, what shape the base is, but the key thing to remember here is the height, okay? The height, again, this goes with the whole idea of it being a trap. The height is the distance between the bases. Distance between the bases. So on here, this is the height from here to here. So don't be fooled, okay? Alright, so that's just kind of your basic idea for a prism. Let's do a cylinder. A cylinder is much like a prism, except that its bases are always circles. Right? Well, here, much like a prism, but the bases are always circles. So I'm going to draw same idea, okay? And there's not really different categories for this. So I'm going to draw kind of, it's a circle, but it's kind of, it's got that, when you look at something in perspective, it kind of gives it a tilt. So here's your cylinder, right? Again, it's not upright. It doesn't have to be upright. It could be. You could have it like this, right? Draw kind of an oval and then like a half an oval and just connect. Right. Now what you want to know about this, or your key values here, would be your radius, which would be here, or if it was this kind of picture, it would be here. And then the height. Again, the height is the distance between the circles. So it could be this way, right? Or it could be from this circle to this circle. Again, I'll shade in the bases. The bases are parallel and congruent. Okay. Parallel and congruent. So this is, we had our prism, that was a polyhedron. Cylinder, this is a non-polyhedron. Okay, let's do a pyramid. A pyramid is classified by its base. Okay. So we'll do maybe 2 examples here. Okay, so let's do a square pyramid. And these are a little bit tricky to draw. And then we'll do next to it a, let's do a pentagonal pyramid. So the square pyramid, we draw this. Okay? Again, try to do this in pencil because we're going to erase some of this away. We have a square, okay, and then above it, you're going to have the high point. It's called the apex point. Okay, the high point, or the point that's directly above the center of the square. So it's a perspective issue. Start drawing these down like so. And this apex period, this point right here, let's call it P, okay? And Q for that, right? So if I go from P to Q, that's the height, okay? So I'm just going to draw that in here. So PQ is the height. Now the height is perpendicular to the base, so you can put a little right angle box in here. Okay. Now here's the thing with pyramids. They have a height, and then they have what's known as a slant height. And the slant height, and try to think like if you were actually at a pyramid, right? This red thing would be if you stood at the top of the pyramid and drilled straight down. Whereas the slant height is if you took a rope and you kind of rappelled down this way, down the side, the midpoint of the side. Now this is a right angle here, going to the midpoint of the side. So we'll call that R. Okay? So that is PR, is called your slant height. And just so you know, when we start doing formulas for this stuff, H is, they use the letter H for height, and they use the letter L for slant height. Okay? And again, if you connect this, and you're going to be doing a lot of these, where they have this drawn for you, and you can kind of draw now from Q to R, and now you have yourself a right triangle, PQR, kind of inside the solid that you could work with. Or you could have, let's say, say this is a 5, 12, 13 right triangle in there. So you're going to see stuff like things that we've done before kind of embedded in the figure. Pentagonal pyramid, I'm going to draw this one a little bit different. I want you to draw a regular pentagon. I guess we should say regular, huh? Because it doesn't have to be regular. So we're going to try and draw it so it's regular. It still doesn't look so nice. Let me try it again. Oh, it's not the best. Okay. We'll just mark it off here. How about that? That old gag. Alright, so that's a regular pentagon. Now what I'm going to do is I'm going to put a point out here. Okay, and that's going to be my apex. But the situation still remains is that it is kind of lined up with the center of the pentagon. So now when I draw all my segments here, right, these you can see, but the other two you can't really see. They're going to be dashed because they're kind of behind it. And one here. Very tricky to draw. It's going to take you a little practice. And again, some of the things that we've done with regular polygons are going to come up here. Things like the apothem, right? Do you remember that? So like right here, at a right angle, that's the apothem. And then the distance from here, from the center to the apex, is your height. Okay, just because it's on its side, it's still called the height. That's something you have to kind of work through. And I'll just give this letters again. W, Z, and I'll put, let's say, T up here, okay, the midpoint of this side. So WZ from here to Z is your height. And then Z to T along the face of it is your slant height. And so that is for pyramids. Okay, this is just the setup for a pyramid. All right, let's get to cone. So now a cone is much like it's like a pyramid. Much like a pyramid, but its base is a circle. You've probably seen that before. It's the same thing, right? So we had prisms and then cylinders, when you made those circles on the ends. And now you have a pyramid, and now when you make that base a circle, it's a cone. So to draw a cone, try to draw kind of a half circle or kind of an oval, and then put a dot up above, and then connect down. And now behind the circle, or behind the cone, you can complete the circle in kind of a dashed fashion, like this. All right. And so we have this, and it's the same situation, okay? Q is the center of the circle, T is the apex, TQ is the height, and then if you walk down the side of the cone, let's say R, right? That is the slant height. So it also has a height and a slant height. Okay? And it's also called H and L. And QR is the radius of the circle. Okay? And when you draw all three, again, this is going to happen on a lot of the pictures. You got that. And a right angle there, so you're going to have right triangles to work with and Pythagorean theorem to work with for that. Okay. The last two, and we'll just put it over here, is your sphere. Okay. Is defined by a point in space. Okay. So you put a point somewhere, and then you basically have a radius, same as you would have for a circle. You have a radius value, and it goes in every direction in every dimension. So to draw this, I'm going to say, draw a circle around this, okay? That's the center. And now I want you to imagine this is kind of like a globe, and I'm going to draw this little arc in here, and this would kind of be like your equator line on the Earth. Okay, and then the back end of the equator where you can't see it is out behind the globe. And again, what I was saying was, it's defined by R in all directions. So it doesn't matter. Usually you would draw it like right out to here, right? And say, oh, that's R. But you could draw it straight to the top here. That's R. You could draw it down to the side here. That's R. You could draw it down here. That's R. Right, so from the center of the solid to its surface is your radius value. Okay. I'll just put here from the center of the solid to its surface. Oops. And that is your sphere. Now a hemisphere, half a sphere, you kind of draw it the same idea, except you're going to start with, I'll just put hemisphere, half a sphere. So, you know, I was thinking now that game Fruit Ninja, right? Fruit Ninja, where you go like this. And so if you imagine Fruit Ninja and the sphere straight across like this, whoosh, and then you would have the top portion like this, still there. Okay, and then it's the same idea, right? From here to the side is R. Here to the top is R, from here out to this point is R, wherever you want to draw it. Okay, so this is your solids that you're going to be working with. There's one other thing I want to kind of touch upon before we end the video, and that is there's a special formula for polyhedra. And we're going to go with, I'm going to make an example here. Let's do a right triangular prism. Okay, so the bases are right triangles, and we're going to put here, I'm going to draw a right triangle. Give yourself, go down the paper a little bit, because we're going to have this kind of moving to the side. But here's a right triangle. Okay, you're going to give it letter designations now, A, B, C. And now I'm going to draw a congruent right triangle out here. Go like this, and we'll call this one DEF. And it's not the straightest, but you get the idea. We're going to connect corresponding vertices. So A to D, we're going to connect that. A to D. And now C to F. And then B to E. Now, B to E is inside. You can't really see it if you're looking down on the solid. So we're going to make that dashed. And also now you'll recognize that you can't really see through the solid at these dimensions of this right triangle, so I'm going to go back in and just dash this. Okay? So that's our right triangular prism. Now, there's different characteristics about all of these solids. The first would be vertices. Okay? We're going to list them over here. Vertices. And the vertices are A, B, C, D, E, F. And then you have the edges. An edge is any line segment that appears in this figure. Okay? Those are edges. So we're going to list those. And that is, I'm just going to go AD, BE, CF. Those are the three that connect the two triangles. And now I'm going to give all the edges of each triangle. So AB, BC, AB, BC, AC, and then DE, EF, and then DF. Okay, so kind of coming up like with the list here, right, of different characteristics. And now the last thing that you can name on a solid is its faces. Okay, the faces are actual polygons. And the different surfaces. So I've got the two triangles. I'm going to name them first. Triangle ABC. I've got triangle DEF. Okay? And now I've got really the three kind of, I've got this kind of ramp looking piece here, right? So that's a quadrilateral, ADFC. ADFC. And then I've got I don't want to say it's the base because it's not the base. Remember, the bases are these things, right? Here and here. So don't really call it the base. I'm going to say the face that it is resting upon is BCFE. And then I've got AB, the kind of the back, ABED. Right, now I want to count these up. Okay. There is what do we have here? 6, 9 here, and we have 5 here. Okay. Now I'm going to leave that list there for a minute. We're going to do another one. So I'm going to erase this. And I'm going to make now, let's do a, hexagonal pyramid. Okay, and all of these, I guess we should say regular. Okay, it's regular. I'm going to make the base a regular hexagon. So we're going to come down here, again, work in pencil. I'm going to have a hexagon right here. Something like that. And I'm going to call this, I don't know, let's see, M, N, P, Q, and R, T. And now I'm going to put an apex up above. I'm going to call that point W. All right, now you're going to start connecting down from W to each vertex. So I'm going to start out here at the furthest ones to the side. Okay, now come from W down to P, W down to Q, and then from W to M and W to T. But now I'm going to start trying to put these in as dashed because we're going to have to change. You can't really see these. These are in the back. Right? So you can't see those, nor can you see the upper half of the hexagon itself because it's kind of now in 3 dimensions. You can't see it. Okay, again, here's the center of the base. I do want to mention one more thing before we go into this the same way. There's actually 2 kinds of pyramids and cones and prisms. There's called right prisms, let's just say, versus oblique prisms. All right, and this goes for really all of them. Prisms, cylinders, cones, pyramids. Okay, a right prism means that this point W is directly above the center. So if I had a prism here, let's just say a rectangular prism. So that's a rectangular prism. So the base, right, so again, these, you could say these are the bases. Really in a rectangular prism, you can orient it anyway and you have rectangles, but with this, right, see the dots, if I were to go straight through, it would be if I just call this A and this B, if I go straight through, drill straight through, the drilling would take place perpendicular to the bases. Whereas an oblique prism, you have, it's like, here I'll draw, here's a hexagon down here, right? And then instead of the hexagon being right above it, it's like out here. Okay? And you have to imagine now this getting to here, to here, to here, to here. Whereas it's pushed to the side, it's probably easier to see it with a cone. So you can have like, here's your cone, right? And if I go drill straight down, I go right to the center. But you can have a cone where it's out here, where it's like on an angle, right? So like if you drill, if you went from the apex and you went straight down, you wouldn't even be inside the solid anymore. You'd be out here. So this is what I mean by oblique versus right. Okay, here. It's easier to see with the cones than these. But back to business. We're only going to be dealing with right solids on your assessments. There might be a couple of oblique ones thrown in. We'll talk about them in the live sessions, but your assessments will be based upon right solids, right cones, right prisms, right pyramids. And so this will always be, if you go from the apex straight down, it'll form a 90-degree angle here. Okay. So we're going to go through the list one more time. We're kind of running at the end of the video here. This is going to be it. Same list. I want you to pause the video here and see if you can come up with a list of vertices, edges, and faces. Okay, pause the video, try it. Okay, so vertices, I've got the 6 that make up the hexagon, and then I also have the apex. So I have M, N, P, Q, R, T, W. Now make sure when you're listing them out, you need to use commas. Okay, so if I see a whole group of, if I just saw a group of 7 letters like that, I would think it's a 7-sided polygon. Kind of like this here. If I just have 4 letters next to each other, that's a quadrilateral. So, you know, I would have to take off. You need to use commas to separate the vertices. The edges, you can use groups of 2 letters. You don't have to put the segment above it, because I know the math editor is being tricky lately. So you can just write, groups of 2 letters, and I'll know what you're talking about. Edges here, you've got every side of the hexagon. So I'm going to start at N and go counterclockwise. So I've got MN, I've got NP, PQ, QR, I've got RT, I've got TM. Okay, so that's 6 for the edges of the hexagon. And now I have every edge coming from W. So WM, WN, WP, WQ, WR, WT. It's time consuming to write it out. You are going to have problems like this on your assessment. Right? Not a whole bunch, but you need to be able to do this. And the faces, I've got the hexagon, MNPQRT. Okay, that's a hexagon. And then I have 6 triangles. So I have, again, it might be easier for you to start in the middle here. You have PWQ, which is coming down on the slant here. Triangle PWQ. Then I'm gonna go to the right side here. And you have QWR, Again, you don't need to use the triangle symbol. I'll know if you just give me the 3 letters. But I'm just trying to keep it legit here. And I've got RWT. And then TWM on the back. And then MWN. And then this last one here, NWP. NWP. Alright, so we've got here, let's count these up, right? We can use different color. I've got 7 vertices. I've got 12 edges. And I've got 7 faces. Okay? So now I have the list for the last 2 problems here, and I want to give you something now which is kind of used to check your work for problems like this. All right, and this is going to be it right here. It's called Euler. It's E, capital E, it's a person's name. E-U-L-E-R. It's pronounced Euler, like oil, right? That's how it's pronounced. Euler's formula for polyhedra. Right? And here it is. F plus V equals E plus 2. So what does this mean? Well, this is F means the number of faces. V is the number of vertices. E is the number of edges. So this is used to check to see if you have a complete list, or maybe you've double counted something, right? So let's check it for the red one, right? All the way on the end, our first problem. F was 5. V was 6. Edges was 9 plus 2. 11 equals 11. Boom. Let's do it for this last one here. Faces was 7. Vertices was 7. Edges was 12 plus 2. 14 equals 14. Boom. Okay, so that is not really, it's a simple formula, but it's worth knowing it because it's gonna give you reassurance when you're coming up, if you're coming up with these lists, and you will be on the assessments, that you have a complete list and you haven't missed one or counted one twice by accident. So that's the first video. Wow, it's a long video. And then in the next video we will get into all of the formulas for the solids.